In this video, we're going to look at what's called bivariate analysis. Now, the kind of questions we're going to answer are, is there a relationship between the amount of sugar people consume in January and the amount of sugar they consume in February? Now, so far, most of what we looked at has been either univariate, just looking at one variable on its own, or perhaps comparing one variable between different groups. Now we're going to look at how we can see how two continuous variables are related. Before we move on to equations or summary stats, the best way to begin is always by viewing a relationship graphically. If we go to our datasheet, and highlight those two columns, the two sugar intake columns that we're going to look at. Use Control, and we can highlight both. And if we head up to Insert, Recommending Charts, we can insert a scatter plot, showing us the relationship between the two. Now we can see instantly that there is a positive correlation here. Means the higher the January sugar intake, the higher the February sugar intake. If the relationship were the opposite, then we'd have negative correlation. For example, the greater the mass of a vehicle, the lower the fuel efficiency. That would be negative. Now, to determine the strength of this correlation, we can calculate what's called a correlation coefficient. Now, the correlation coefficient is a number between 1 and -1, where 1 means perfect positive correlation, and -1 means perfect negative correlation, and 0 means no correlation at all. Now, Excel can do this quite quickly for us. If we open up a new sheet, let's call it Jan versus Feb. And actually, I'm going to take our scatter plot that we've created and pop it in there as well. Keep things tidy. Now, what we're going to do is we're going to calculate the correlation coefficient. We're going to do equals correl, open brackets, and then we choose the two. That one, comma, that one. Choose the two variables that we want to compare the relationship of, hit enter, and immediately we get told that the correlation coefficient between Jan intake and Feb intake is 0.80 to 2 decimal places. Now, what does that mean? That's close to 1, so it means we've got a strong positive correlation. If the number were closer to 0 but still positive, then we'd have a weaker positive correlation. We might have a weak positive, we might have moderate positive, but we've got strong positive correlation here. Now, it's worth noting that even with two variables that aren't actually correlated, we could still get a correlation coefficient of something that's not 0, maybe 0.2 or minus 0.3. We could still get that just by chance, just because of the way the data sits. Now, what Excel is actually doing when it calculates this is it's seeing how closely these points are to sitting in a straight line. If they sat in a perfect straight line, we'd get a correlation of exactly 1. And that's what the correlation coefficient is measuring. If we had a relationship between two variables that wasn't linear, so it wasn't a straight line, but maybe it was a curve, or something like that, then the correlation coefficient wouldn't actually pick up on that, and it might turn around to us and say, no, there's no correlation here, when actually, if we plotted it graphically, we would be able to spot this relationship. There might be some non-linear relationships in this data set, so do see if you can find them. Now, we can go one step further, and we can use this strong relationship to make some predictions. If we right-click on the scatter plot and select Add Trendline, which might also be called a line of best fit or a regression line, this is the line that is closest to all the points as possible. Now, we can actually view the equation of this line in the y equals mx plus c form. If you don't see this menu, then just double-click on the line. If we scroll down and click Display Equation on Chart, we just move that equation so we can see it a bit more clearly. This gives us the average relationship between x, somebody's January sugar intake, and why somebody's February sugar intake. When you're plotting two things against each other, do check that Excel has plotted them the right way around. You can see that it will give you the y-axis name at the top, so make sure it is the right way around. Now, if somebody who consumes maybe on a normal month 3,000 grams of sugar, and they come to us and they say, how much sugar do you think I would consume if I did sugar-free Feb? We could substitute 3,000 in here as our X and tell them. Now, let's do that. If we say, okay, that equals 3,000 multiplied by our 0.8234, and then we want to take away 814.19, hit enter. We would tell that person, we estimate that in February, if you did sugar-free Feb, you would consume just 1,656 grams of sugar. Now, obviously, this model has ignored all other factors such as age, gender, motivation, things that will probably make a difference to that prediction. And so it is possible to improve our model to incorporate that too, but that goes well beyond the scope of the A-level syllabus. A-level maths just focuses on bivariate regression, which is using just one independent variable to predict our dependent variable. Now, using the regression equation to make this prediction for Mr. 3,000 grams is called interpolation. Now, interpolation is an estimate that is within the bounds of the data we have. So we do actually have data already for people who consume 3,000 grams of sugar. And so that is within the bounds of what we've got. We've got data from 500 grams all the way up to about 4,500 grams. So anything within there would be called interpolation. Now, as long as we bear in mind that this is only an estimate, interpolation is generally seen as acceptable. It's okay to do. Now, on the other hand, if somebody with a January sugar intake of 6,000 grams or maybe 20 grams came along and asked us to predict what effects sugar-free Feb would have on them, our prediction would be far less robust because that would be extrapolating. We're going outside of the bounds of our data. We're using this regression equation where it shouldn't be used. We don't actually know what happens beyond this point. We don't know what happens beyond this point. And so extrapolation, it's possible to do, but it is bad. And quite a typical exam question is you'll be asked to substitute something in that will be extrapolating, and you're asked to comment on the reliability of your results. And your answer is our results are not reliable because we are extrapolating. It wouldn't be right to talk about correlation without mentioning the difference between correlation and causation. Now, going back to our correlation coefficient, it's told us that there's a strong relationship between these two variables. Now, that's not surprising. We would expect somebody's February intake to be strongly associated with their January intake. However, there's a real distinction between correlation and causation. Just because two variables are correlated, it doesn't mean that one is causing the other. There may be other underlying factors, a confounding variable that's causing these two things to be correlated. A really great example is ice cream sales and shark attacks. When ice cream sales are higher, shark attacks are more common. So the conclusion, don't buy ice cream, kids. No. What's the confounding variable here? Might be the number of people on the beach that's affecting both. It might even be the temperature. When we have a higher temperature, ice cream sales are higher. When we have a high temperature, shark attacks are more common. And so these two things, yes, they are correlated, but one is not causing the other. And even if even if there isn't causation there, we can still interpolate to make predictions. We could still say, okay, there were 10 shark attacks on a beach this day. How many ice cream sales do you think there were? And that might give us quite a reliable estimate. On the other hand, sometimes correlation can be down to pure coincidence. There's a really nice website that highlights some amusing coincidental correlations. If you Google spurious correlation and head to this website here, it's highlighted quite a few that have come up with real life data. We've got the number of people who drowned by falling in a swimming pool in a particular year correlates with the number of films that Nicolas Cage appeared in a year. Correlates quite nicely there. Per capita cheese consumption for each year correlates with the number of people who died coming tangled in their bed sheets that year, and so on. So clearly these things just can happen by chance. So always take correlation with a pinch of salt, and definitely don't assume that one is causing the other. Okay, have a go at these exercises, check your answers, then move on to the next video.